Welcome to the deep dive. Today, we're jumping right into something pretty exciting in AI, these new unified models. For a long time, AI was sort of split, right? You had models that could understand information or models that could create it. But now we're seeing systems that, well, do both. They can intelligently grasp and generate stuff across different types like text and images all together. It really feels like a new chapter. AI isn't just smart anymore, it's genuinely creative. So our mission today is to unpack a brand new model. It's from Alibaba Group's Ovis team, and it's called Ovis-U1. We're going to try and peel back the layers on this thing, figure out what it can really do, and look at the innovative ways they actually built it.
Yeah, and this couldn't be more timely. It really builds on breakthroughs we've seen recently, like OpenAI's GPT-4, which also kind of blurred those lines between language and images. What's really fascinating about Ovis-U1, I think, is that it hits two core questions head on. Questions that are, shaping where AI is going. First, how do you actually give a model built for understanding the power to also create amazing images? That's a big jump. And second, maybe even more profound, can training these two things together, understanding and generation, actually make both of them perform better? Ovis-U1 seems to suggest, yeah, it can.
Okay, let's dive right into the what can it do part then. Because Ovis-U1, even at just 3 billion parameters, seems to have, well, let's call them three main superpowers, and they really push the envelope.
That's a good way to put it. Superpower number one is really solid image understanding. Ovis-U1 doesn't just glance at an image. It deeply comprehends it. So you show it that picture of French fries, right? It doesn't just output fries. No, it gives you this detailed rundown. The image shows a kitchen countertop with freshly fried French fries. There's a deep fryer in the background, a bowl of fries, a jar of ketchup, and a tomato. The countertop is made of granite with a speckled pattern.
Wow, that's specific.
Exactly. But it gets better. It's not just objects. It can actually read and understand text inside an image. So you could show it a photo of, say, a riddle. It reads it. Why did the boy think his clock was hungry? It went back for seconds. Or what begins with T, ends in T, and is filled with tea. A teapot. It's combining vision and language in a very almost human-like way.
Okay, that's impressive understanding. What's superpower number two?
Number two is more straightforward, but still crucial. Text-to-image generation. You give Ovis-U1 a description, a text prompt, and bam, it creates a totally new, pretty high-quality image just from your words.
Standard, but necessary for a unified model.
Right. But number three, this is where it gets really interesting. Its third superpower is image editing.
Editing. So changing existing images.
Precisely. It can take an image you already have and modify it based on your text instructions, like really specific instructions. Think about removing something distracting from a photo instantly or completely changing the art style with just one sentence.
Okay, give me some examples. This sounds cool.
Okay, so you can take a picture and tell it, adopt the art style of Jun Miyazaki's animated films.
Oh.
And it just transforms it.
Right.
Or adding things. Add a small wooden cabin with a chimney near the edge of the forest on the right side of the image.
Whoa.
And removing things too, like remove the armchair with wooden armrests and checkered upholstery. Gone. It can even do these complex replacements, which is kind of mind-blowing. Think about this. Replace the yacht in the image with a hot air balloon floating just above the ocean's surface.
You're kidding. A yacht for a hot air balloon. How does it make that look natural?
That's the thing. It's not just cutting and pasting. It integrates the new element, adjusts lighting, perspective. It's remarkably seamless. And it handles tiny details, too. Things like replace text 95 with 123 on an image of a cookie.
On a cookie? Seriously?
Seriously. Or it could change the color of bags to silver in a picture of luggage. Or even change materials. Replace the bench's material with marble on a photo of a snowy bench. Or change entire backgrounds. Change the background to a forest for a bear that was originally in water. Removing tiny things like remove the peanuts from a bird's beak. Adding big things like add a modern skyscraper in the background to a landscape. Even swapping objects completely. Replace the dog in the image with a sunflower sticking out of the car window.
Okay, that's genuinely mind-blowing, especially the yacht to balloon thing or changing numbers on a cookie. It's not just basic editing. It clearly understands context and composition. So, all right, let's unpack this. How? How did the Ovis team actually engineer this thing to be so good across understanding, generating, and editing? The how must be pretty clever.
You nailed it. The real magic is under the hood. It's in the architecture and the way they train it. Ovis-U1, it builds on their earlier Ovis models, sure, but they've added some really crucial enhancements. Architecturally, a big piece is this new visual decoder. It's based on a diffusion architecture.
Diffusion, like those models that start with noise and refine it.
Exactly like that. Think of it like a digital artist, starting with a blurry canvas and gradually bringing a sharp image into focus. Specifically, they use something called a multimodal diffusion transformer, MMDIT for short, and it incorporates rotary positional embedding, or ROPE.
Okay, technical terms there. What does Ropey help with?
Imagine that artist again. ROPE is like giving them perfect memory of the exact 3D position and angle of every single brushstroke they make. It helps the model handle the spatial relationships within the image incredibly accurately, vital for high-fidelity generation.
So it's giving the model a really precise internal map of the visual space it's working with.
That's a great way to think about it, yes. And then there's this other component, a bidirectional token refiner.
Bidirectional, meaning it goes both ways.
Exactly. Picture it like a constant back-and-forth conversation between the text description and the visual parts of the image, whether it's seeing or creating. This refiner makes sure the text understanding and the visual generation are always tightly linked. It really boosts the quality of the generated images and the accuracy of the edits. Now, here's a really key difference from some other approaches. Instead of starting with a pre-trained multimodal model, Ovis-U1 is initialized from a standard, but very capable, language model. It's called Qwen 3 1.7b.
Ah, okay, so it's like teaching a really eloquent speaker how to paint, rather than starting with someone who knows a bit of both, giving it that strong language foundation first.
Precisely. That deep linguistic understanding from Qwen 3 gives it a massive head start. Then they train it with all the visual understanding and generation data. And this unified training, building on that language core, is a huge part of why its overall performance is so strong across everything. The visual encoder part, the bit that processes the incoming images that comes from AIM v2 large, and it's designed to handle basically any image resolution you throw at it. Size, shape, doesn't matter. And that refiner we talked about, it uses a special technique, a learnable CLS token, instead of the more common CLIP features, to get a better grasp of the overall image context when it's generating or editing conditionally.
Okay, that sounds like a really sophisticated setup. The parts aren't just existing together, they're actively collaborating and learning from each other. So what does that mean for how they actually train it? Is the training strategy the secret sauce here?
Absolutely. Yeah. That leads right into their unified training strategy, which is pretty distinct. They don't just mix everything together randomly. They use 3 specific types of multimodal data. Each type trains a different skill. First, there's multimodal understanding data. This teaches it to comprehend images. Think huge data sets like COIO, Wukong, LAN, ShareGPT-4v, CC3M, plus their own internal data. This is the what things are training. Second, text-to-image generation data. This teaches it to create images from text descriptions. Sources like LAN-SX and JourneyDB are key here. And third, this really rich category they call image plus text-image generation data. This is where the editing prowess comes from.
Oh, the editing data.
Yeah, it covers everything. General editing from datasets like OmniEdit, UltraEdit, SeedEdit.
Yeah.
Then more advanced stuff like reference-driven generation.
Like giving it an example image for style.
Exactly. Using data from Submix 200K, SynCD, Style Booth for that, and even pixel level control using Multigen 20M. Plus, again, their own custom datasets for specific tasks, like removing objects or transferring styles.
That is a huge amount of varied data. How do they manage all that? How do they make sure the model learns all these things effectively without, getting confused?
That's where the unified strategy really comes into play. They use this careful, 6-stage progressive training process. It's not just about feeding it data. It's structured to deliberately balance and integrate the knowledge from all these different tasks. Think of like cross-training for an athlete. You practice different skills, right? You don't just get better at each one individually. You become a more well-rounded, adaptable athlete overall.
Okay, that makes sense.
Same idea here. This unified staged approach helps the model develop these more general, universal ways of representing information that work for both understanding and generation. Each task helps the others. That collaborative training is really a cornerstone of Ovis-U1.
Right. So bringing it back, what does all this clever engineering and training mean for, us? Why should you, the listener, care about Ovis-U1?
Well, it matters because Ovis-U1 packs a real punch, especially considering its size. It's only got about 3.34 billion parameters total.
Which is pretty compact in the world of these big AI models, right?
Definitely. Many leading models are significantly larger. But performance-wise, Ovis-U1 holds its own. Let's talk understanding. On the Open Compass Multimodal Academic Benchmark, think of that as like a tough final exam for AI vision and language skills. It scores 69.6.
Is that good?
That's really strong, yeah. It shows it genuinely understands diverse visual info objects, text, answering questions about images. It competes well with models in its parameter range like Ristretto 3B and SailVL. But here's the kicker, the really significant finding. that unified training actually boosted its understanding score by 1.14 points compared to if it were just trained on understanding alone.
Wait, so training it to generate images made it better at understanding them?
Yes, that's a big deal. It kind of flips the script on the idea that making a model a jack of all trades weakens its specialized skills.
Yeah.
Ovis-U1 shows you can actually get smarter overall by unifying these tasks. It's a leap towards more general AI.
That is fascinating. So it's not just doing well, it's actually improving its core understanding because it's also learning to be creative. What about the generation and editing benchmarks?
Also strong. For text-to-image generation, it gets 83.72 on DPD Bench and 0.89 on Genival. These basically measure image quality and how well the image matches the text prompt.
So it draws well and draws what you ask for.
Pretty much. And its scores are competitive with much larger models, even though its visual decoder part is only about 1 billion parameters. And for image editing, it scores well to 4.00 on ImEditBench, 6.42 on JEditBench E. These tests look at how precisely it makes requested changes while keeping the rest of the image intact. Its performance is also stable. You can tweak the guidance settings, how strictly it follows your instructions, and the quality stays consistently high.
Okay, so it performs well across the board. What's the practical takeaway then?
The practical implication is that this model, at around 3.6 billion parameters all in, hits a sweet spot between power and efficiency. What that means for you, potentially, is having access to really capable multimodal AI for graphic design, content creation, maybe even AR, without needing, a supercomputer to run it. It's powerful, but potentially much more accessible.
That definitely makes Ovis-U1 feel like a significant step. It's really pushing what these unified models can do, understanding, generating, editing all together. It shows how far things have come.
Absolutely. And the researchers themselves point toward the future in their report. One obvious path is just scaling up bigger models might help reduce some of the visual glitches or occasional weird outputs, leading to even higher quality images. Another huge area is improving the training data, getting more diverse data, higher quality data, and especially more interleaved data.
Interleaved, like text and images mixed together naturally.
Exactly, like you see on a web page or in an illustrated book. Training on that kind of data could make the models even better at understanding context. We'll also likely see more innovation in the model architectures themselves, things like specialized designs, to make image editing even better at preserving those really fine details when you change something.
Makes sense.
And then there's this really big ongoing challenge, reinforcement learning from human feedback, or RLHF. It's about how we teach these incredibly powerful models to better align with what humans actually prefer, aesthetically or functionally, going beyond just technical accuracy to capture, human taste and intent. That's a major open research area.
Aligning these powerful tools more closely with what we actually want. That's definitely something to watch. It makes you think, doesn't it? As AI models keep learning and integrating knowledge from all sorts of information, much like we do, what new kinds of creativity, what new ways of solving problems, what deeper understanding might emerge? What complex visual challenge would you want to tackle with a tool like Ovis-U1? Something to mull over.